Hello guys, Assalamualaikum warahmatullahi wabarakatuh and very good day. So today we're going to talk about again electrochromic supercapacitor. So little bit history why I dive into this electrochromic supercapacitor. So this is the first application that give me the pay for my PhD. So when I finished my PhD, I start for RA or research assistant for almost 1 year and 1 year, almost 1 year. Then Alhamdulillah after that I got the opportunity as a postdoctoral, and the first application that demand me to dive into is electrochromic supercapacitor. So let's talk about it. Electrochromic supercapacitor just combine two application. You got the electrochromism, the ability to change color upon a small potential apply, and also you got the supercapacitor, the device that can store energy, charge. So, combining why first we're going to talk why these two is good, can merge together, can combine and produce one useful application. Why? Because we are talking about shared mechanism. Both shared one mechanism that simultaneously can change color at the same time. What it can do is it can store the charge. So what is the mechanism? It is redox process. So redox is about a reduction and oxidation. It's about the gain of electron and loss of electron. So typically when we are studying supercapacitor or electrochromic material, we're dealing with the transition metal oxide, conducting polymer, and even mixing the hard 2D emerging material nowadays. So, out of all these material, all have one similarity. All needs the redox process. Because let we take example for transition metal oxide. So transition metal oxide can change color upon you change the potential, like positive 2 to positive 3, positive 3 to positive 4, the color is different. So by taking input about the material capability to change color, like transition metal oxide have multiple oxidation states. Various color is expected to be seen when you apply different potential. Then here the useful application electrochromic supercapacitor come into the surface. So basically in terms of analyzation, in terms of characterization, almost the same with supercapacitor. You run the 3 electrode system, 2 electrode system. In addition, you run the electrochromic analysis. So you can hear my daughter sound at the back. So electrochromic analysis, you just add on about the UVVs by having the in situ transmittance, in situ absorbance. Then you can calculate the optical contrast, the coloration efficiency, and in the end, you got a very complete one to run the electrochromic supercapacitor. If you have a machine called potentiostat equipped with the UVVs for in situ UVVs, it's better. That's the very good system. I can recommend one from the brand Autolab. They have that system together with the potentiostat. With that system, more than 100k. You need to find more grant to buy that. If you want to find the separate one, you can do, but not that accurate. You can you can apply certain voltage and measure the transmittance and absorbance separately. It will be a little bit tricky and hasty compared to the merge one, the what we call that the in situ one. So it's highly recommended for you to buy the in situ one if you want to run the electrochromic supercapacitor. And in terms of possible application, what possible application it can go through, you can go for smart window application. Because like normal window, when the sun is very bright, so all the sunlight will pass through the window, and even some irradiation, some UV light will also pass through the window and then 100% of that will make you become older and older because of that radiation. So by having a window that can change color upon certain voltage, because we know that the light from the sunlight, the source of light is photon. Photon carry a package of energy that produce a range of voltage. At certain voltage, your window can change color and block some of the light. That can also protect your skin from the irradiation and so on. So comparing between the traditional blind and so on, traditional blind is okay. You can go to colorful. Upon Hari Raya Deepavali, you can change your langse, your blind. But nowadays, people go to the AI. Everything goes modernization. So they don't need a traditional blind. They need the window to change color automatically. So that's the idea. We want to change simultaneously, automatically. That's the what we call that the technology of smart window from Electrochromic Supercapacitor. I think that's all. So after a long time not make a video, so that's it. Okay, see you again. Bye bye.